Hi, my name is Anise.
And I'm Amanda, and through this pre-calc video we will be teaching how to convert radians to degrees, how to find radians, linear speed, angular speed, circumference. We're going to be working with the unit circle, finding arc length, the area of a sector, and describing code rectangles.
So, my sister had a hamster, and so I did a hamster wheel. I found the diameter, angular speed, and linear speed, and the arc length of the hamster wheel.
And we also went to the bar fair and rode a Ferris wheel to mathematically find the linear speed, circumference, angular speed, and area of a sector for them as well. Thank you.
We hope you enjoy the video. Okay, so I did the hamster wheel, and the diameter of the hamster wheel was equal to 8 inches. So I did to find my angular speed, I had to watch really closely to see how many revolutions the hamster was running. So the hamster was running really fast, so I decided to not do revolutions per minute, but revolutions per second. And so I'm going to go on a guesstimate of 2 revolutions per 1 second. So angular speed is done in radians per minute, so I'm going to times this by 60 seconds over 1 minute to cancel my seconds, and then I'm going to times that by 2 pi radians over 1 revolution to cancel my revolutions, and that's going to equal 753.982 radians per minute. Then I'm going to do linear speed. So to do linear speed, I have to work out my circumference first, which is 2 pi r. So my circumference is going to be 2 pi, and since my diameter is 8 inches, my radius is going to be 4 inches. So my circumference in total is going to be 25.133 inches. So linear speed usually goes to miles per hour, but since it's in revolutions per second, it's going to be a little bit drastic, so I'm going to do it in feet per minute. So again, 2 revolutions in 1 second times by 60 seconds in 1 minute to cancel my seconds to get to minutes, then times by my circumference, which is 25.133 inches over 1 revolution to cancel my revolutions, and then times by 1 foot over 12 inches to get it in feet, and that's going to equal 251.33 feet per minute. And that's my linear speed and my angular speed. So to find the arc length, I'm going to use the formula S equals R pi theta. So theta has to be in radians, and since I haven't converted it yet, I'm going to do that now. So my arc length is, the angle of my arc length is 60 degrees. So to convert that to radians, I'm going to multiply that by 2 pi radians over 180 degrees. So then 60 and 180 cancels out into a multiple of 3, and then I'm left with pi over 3 radians. Then I can go ahead and do my conversion. So I go again and say S equals R theta. So S equals R, if you could remember from the previous calculation I did, that R is 4 inches since my diameter was 8. So 4 inches multiplied by pi over 3. And that's going to give me an arc length, which represents S, of 4.189 inches.
Okay, so for measuring the Ferris wheel, first we will find the angular speed. The height is 264 feet, but half of that, or part of that, is the raising of the Ferris wheel above the ground. So the diameter of the actual wheel itself is 250 feet. Okay, so for angular speed, we have 1 revolution per minute is how fast it goes, and we're going to multiply that by 2 pi radians over 1 minute, or 1 revolution. And cancel them out, and you get 2 pi radians over 1 minute. Next, we'll find the circumference. The circumference is 2 pi r for the formula, and when we input our radius, which is half of the diameter, 125 feet, we get 2 pi 125 equaling 250 pi feet, which, when calculated out, is 785.4 feet. So we're going to take this use of the number and input it into the linear speed formula. And we put 250 pi feet over 1 revolution. We multiply this by 1 revolution over 1 minute, which is the beginning of the linear speed. Next, we will convert to miles. So we will cancel out the feet, putting 500,280 feet over 1 mile. Next, we will cancel out the minutes, multiplying 60 minutes over 1 hour. Cancel out minutes and feet and revolutions, equaling 8.925 miles per hour, which is nearly 9 miles per hour. That's how fast the Ferris wheel is going. Today we'll be finding the area of a sector for the Ferris wheel. The formula for this is 1/2 radius squared times angle theta. The angle we are finding is 120 degrees, and we have to input it in radians, not degrees, so this will be 2 pi over 3. When we input this, our radius is 125 feet, and this will be 1/2 125 squared times 2 pi over 3. When this is calculated out in radian mode, it equals 16,362.462 feet. Thank you. To identify coterminal angles, you must begin at the initial side on the x-axis in between quadrant 1 and quadrant 4. This first angle drawn is a 45-degree angle rotating counterclockwise, terminating right here in quadrant 1. The next angle drawn will rotate clockwise, beginning in the opposite direction, and will terminate in the same location. This angle, however, is not described as 45 degrees, but rather negative 315 degrees. But they still terminate at the same location in quadrant 1, therefore are coterminal.